When a star much larger than our Sun is nearing its end of life, the star goes supernova, the most intense explosion ever witnessed by humanity. This phenomenon can be more luminous than the combined light of all the stars in the Milky Way, and it's so potent that it can generate as much energy in a single day as our Sun does in a whole year. So put on your 3D glasses and get ready to learn about the science behind a cosmic explosion. Now let's get started. Before we can talk about the big hypernova, we'll need to talk about its little brother, the supernova. There are two ways this kind of smaller explosion can happen. The first one can happen in a binary system, where two stars orbit each other, and the second one comes from a white dwarf. When a smaller star's core has run out of fuel and is about to die, in the end, they turn into white dwarfs, which have no energy source inside. Their gravity makes them fall apart, which makes them very dense. Sometimes they are as dense or as denser than the planet Earth. A typical white dwarf is about the size of Earth and has half the mass of our Sun. Slowly, they will get colder, and when they are completely cold, they will turn black. Dwarfs live in a binary solar system, which is made up of two stars that are so close together that they orbit each other. The white dwarf can start to make material from its brother star. As the mass builds up, the white dwarf gets denser, and when it gets too dense, the star explodes with a big bang, making a supernova. The second type of supernova happens when giant stars die. When a star at least 5 times bigger than our Sun is about to go out, it will burn out in a huge explosion in space before they die. All stars live because of a delicate balance between two strong forces: the star's gravity, which tries to squeeze it into a tight ball of mass, and the force which is opposite to gravity. The star's nuclear fuel is what puts pressure on the outside of the star. When a star's core is burning, gravity starts to win over all its nuclear fuel, and after many years of this, the star falls apart in a big way. Huge shock waves are sent out so quickly that the outer part of the star blows up in a bright, powerful explosion. A typical supernova can shine as brightly as 10 billion suns and release as much energy as 10 to 44 joules. Astronomers think that 1 or 2 supernovae happen on average every century in our galaxy. Earth hasn't been affected by a supernova in a very long time, but the explosion happened 325 light years away, which is 6.5 times farther away than the danger zone. But Earth was still changed in some way after 50 light years. But what is a hypernova? A hypernova is like a supernova on steroids, making an explosion that is 100 times stronger. Hypernovae are so powerful that in the first few seconds after the explosion, they can release 10 to 16 to 10 to 19 orders of magnitude more energy than the Sun does in its entire lifetime. This means that one hypernova can supply all of Earth's energy needs for a very long time. The latter is very rare, and it is thought that only a few dozen have been seen in the last few decades. Still, experts aren't sure what makes a hypernova so big. Here are 3 most likely ways that hypernovae forms to help you understand. In the first case, the collapsing star or collapse model says that when a massive fast-spinning star with at least 15 times the mass of the Sun runs out of nuclear energy, its super-compressed core is crushed by the star's gravity and folds in on itself. A black hole can form if the right things happen. If a smaller star explodes into a supernova, the same thing could happen. If a lot of the mass it threw away falls back onto the crushed core, the uncountable tons of matter around the star will start to swirl and flow into the black hole, and 2 jets of matter will start shooting away from the black hole at speeds close to the speed of light. These jets can last for a few seconds and send out bursts of gamma rays that last for a very long time. If you use a telescope to look at them, they put on a beautiful light show. It was thousands of light years away. The second idea is that a lot of electrons and positrons, which are called particles and antiparticles, find their missing halves in the center of a big star and make dangerous gamma radiation. The opposite process also happens, and if certain conditions are met, this cycle can go on forever inside a star. This cycle could get just a little bit off, causing too many pairs of particles to form. If that happens, the star won't be able to keep its core under control and it will explode in a hypernova. The last scenario is a lot like solar systems with two stars that go supernova. If everything goes perfectly and one of the stars explode in a place and at a speed of light where its material falls right on its neutron star brother, the neutron star becomes a very dense and unstable neutron ball, which could cause an explosion. It is a bigger version of a supernova explosion, and one day it might turn into a hypernova, which would be a great show. Scientists still don't know which is the most common of the three. Every supernova is very dangerous, but how dangerous is it? If we told you that a normal supernova or even a hypernova could make a planet like Earth uninhabitable if it happened close to our solar system, you wouldn't be surprised. Imagine that there is a huge star that is 10 times bigger than our Sun and it's only 25 light years away from our poor little planet. What would happen? Well, the explosion would send a huge number of invisible neutrinos hurtling towards Earth. These neutrinos move quickly and can't be seen. These are very small, slippery, high-energy particles that get stuck between the dying star's core and its atmosphere. They would get there quickly, almost as fast as light, but they would be the least dangerous. When an uncountable number of photons reach the Earth's atmosphere, a person on the surface of our planet would be able to see the spectacular explosion of the star with the naked eye. It would be like a tiny blind spot in the sky, much smaller than our Sun, but still very dangerous. In addition to visible light, the exploding star would send X-rays, gamma rays, and hard ultraviolet radiation into our atmosphere, which would destroy the ozone layer. We know that all life comes from sunlight, and that destroying the ozone layer, which acts like sunglasses for our planet, kills all life. There would be changes that are hard to imagine since there would be less ozone and more UV light would reach the surface. Even a 10% rise in ground level can kill some organisms, like phytoplankton, that are sensitive to UV light. Since most of the oxygen on Earth comes from these organisms and they are at the bottom of all marine food chains, any big change to them could lead to mass extinction. But for this to happen, the supernova would have to happen closer to Earth than 50 light years. Also, any supernova closer to Earth than 1000 light years could still have a small effect on the biosphere, but it would be much smaller. But a hypernova can kill you even if you're 10,000 light years away, because its jets send out gamma rays at speeds close to the speed of light. But the jet would have to be aimed right at us to kill us. The GRB 031203 burst, which was the one that was closest to Earth, was many light years away. As you know, this was completely safe. But since space is so big and most big stars are many light years away, this isn't a big deal. We don't have to worry about too many stars that could die soon. At the moment, there are no stars that could go supernova that are less than 50 light years away from our solar system. There are also only 6 candidates for a nearby supernova within 1000 light years of Earth. Ikpekasi, which is 150 light years away, is the giant star that is closest to us. People think that by the time it could explode, our solar system will be far enough away to be safe, since our paths through space are similar. In the past, many experts seemed worried about Betelgeuse from the constellation Orion, which is a very old star that is 15 times the size of our Sun. But research has shown that even in the worst case, we have less than a 1% chance of seeing that star go supernova in our lifetimes. Most likely, the material it throws out won't hurt the Earth directly. A supernova explosion might have some effects on the Earth's environment, but since it's too far away to hurt our atmosphere, those effects will be small. We want to tell you a cool story about a hypernova as a bonus. In 2016, a group of astronomers saw something bright in the sky that wasn't like anything else. When they looked into it, they found it was the most powerful supernova they had ever seen. The ASA SSN 15LH, which is in a galaxy far away from us, was very powerful. It was about the size of our Sun and was almost 200 times brighter than a typical supernova. Let's hope that even if we see a small supernova, it will be far enough away that we can watch the fireworks and learn more about this amazing event without worrying that it will hurt our solar system. Now, What was the actual explosion that baffled scientists? Gamma-ray bursts are among the universe's brightest and most explosions. They are so powerful that they can create gold out of thin air. Scientists were able to observe the explosion despite its short duration. It was caused by the merger of a neutron star with another star. This was documented in a study that will be published in the Astrophysical Journal Letters, a peer-reviewed academic journal. Gamma-ray bursts are more energetic than the Sun. A gamma-ray burst is simply a massive explosion of gamma-ray light, the most powerful type of light. Typically, they can last for a few milliseconds or a few minutes. However, they maximize their little time in the spotlight. Neutron stars are also uncommon, making this discovery even more peculiar.